I know where there's some, right here in the hall, clerk.
No, Molly, I have
Now we want to check out the IF transformers. This is the first IF transformer here, the second one is here, and by 1940 or so, everybody, I don't know about Philco, certainly Zenith, were bringing the transformer leads out to pins on the bottom of the can, so you could measure them easily. Philco in 1935, 36, whenever this was built, weren't yet doing that, so the leads come out and run to various places, and they're very difficult to get to from the chassis. The first IF transformer is buried under here. The second one is buried under this capacitor, bakelite capacitor here, there, so you can't really get to them. And even if you could get to them, you couldn't measure anything anyway. You have to take them out and go directly to the probes, or to the wires inside the can. So what you have to do is go around. In this case of the first IF transformer, let's look at the primary, which is here. The primary is connected to pin 2 of the 6A7, and then down here it goes to a 32K resistor up into the base of the primary of the second IF can, but it also goes over here to pin 3 of the 42 tube, and that's where we can pick it up most easily. So if this transformer is in good shape, we should see, what's that say, 34 ohms between pin 2 of the 6A7 socket and pin 3 of the 42 socket. So let's, pardon me, so let's see if we can get that set up. Okay, pin 2, the 6A7 socket is right here. Lift this cap out of the way a bit. And we're after pin 2, the two big leads on this socket. Let's see if I can zoom in a bit here. The two big pins, rather, are right here and right here. So going clockwise from the bottom, this is pin 1. So our pin 2 of the 6A7 is right there. And we'll put a lead from the DVM to there, if I can get it untangled. Pin 2 is here. And then pin 3 of the 42 tube. The 42 tube is in this corner right here. And I'll go to pin 3 of that one. Yeah, here are my big pins, so 1, 2, 3. So pin 3 of the 42 tube is there. Turn on the ohm meter. And it's open. Yeah, it's too bad. So there's a break. Probably, and Philcos are known for this, there's a break most likely in this primary section of the first IF transformer. Now let's take a look at the secondary of the IF transformer. The other side of the secondary of the first IF transformer goes over here to capacitor 7. So let's see if we can find capacitor 7, which is this guy right here. So this side of capacitor 7 goes to ground. This one is the center. This looks like it has 3 caps in it. Well, 2 caps. Here's the ground. Here's another cap. Here's another cap. So the question is, which one of those would lead us to the correct place? Well, let's start by hooking up to the tube. I misplaced my pointer. The 78 tube, it's right here. The grid cap of that goes directly into the secondary of the first IF. And if you look down here, here's where the 78 tube goes, and this wire is the grid cap wire that comes from, depending on which way you think about it, but from the transformer into the grid cap of the 78 tube right here. So one end of the ohm meter goes to this grid cap, which I will do right now. And the other end of the ohm meter goes to capacitor 7, 0.05. The capacitor 7 is this guy right here, as I recall. Yes, that's this one right here. So we should be able to clip right on there. Take a look at what our ohm meter says. And it says 45.1 ohms. Back to the schematic, and the secondary of the first IF transformer should be 47 ohms. So 45 ohms is close enough. So the secondary is good here. I'll color code that. Oops, sorry. This one is open. This one is good. Okay, we'll move on to the second IF transformer right here. The top of the second IF transformer primary is connected to pin 2 of the 78. The bottom of it we can pick up again on pin 3 of the 42 tube. So I'll set that up. Okay, we have pin 2 of the 78, which is right here, and pin 3 of the 42. The 42 is in this corner, and it's 1, 2, 3. So this is pin 3 of the 42 tube. And we have 33.3 ohms. Schematic calls for 34. So we've got a good primary on the second IF transformer. So that's good. I'll color code that. And now the secondary of the second IF. The top of the secondary goes to pin 3, it looks like, of the 75. The bottom of the secondary goes to capacitor 27 or resistor 28. Let's find capacitor 27. By the way, when I refer to finding them, I refer to this sheet right here. This is out of the schematic for this radio and the parts location. Some of these that you'll download, this will be nearly invisible. I found a good copy here. And our capacitor 27 is right here. And that's pointing, there's a bakelite block right here, and that's pointing to that tab of the bakelite block. So I'll find that. Okay, pin 3 of the 75 tube. 1, 2, 3 here. And then capacitor 7 on this bakelite block is the middle one. And that's coming up as 44 ohms. And the schematic shows 85 right here. Okay. So that is probably okay. We're getting about 45 ohms across here. So I'll call that provisionally okay. I'll leave it unmarked. So that takes care of our IF cans. We know we have one problem with the primary of the first IF can. The second IF can may be okay. So we'll presume it is for now. That leaves 2 more transformers that we want to take a look at. One is the antenna here, and the second is the oscillator here. Pardon me. So we'll check and see if we have, what should that be? 1.6 plus 0.5 plus 3.3. So we should have some around 2.5, 3 ohms across this whole transformer on the primary side. We should have 3.4 ohms across it on the secondary side. Over here, same sort of thing. Should have 5.6.5, 7.5 ohms from here to here, and about 11 from here to here. So we'll see. We'll see. Okay, to check out continuity through the primary of the oscillator coil right here, we'll go from pin 5 of the 6A7 through to capacitor 13, this side of capacitor 13. And again, we should have 2.3, around 2.5 ohms. So let's see what we can get out of it. 1, 2, 3, 4, 5. Pin 5 of the tube. And the capacitor is this mica mold right here, which will be replaced. Mica molds are actually waxy paper caps stuck inside a plastic container. They usually fail. They're no more reliable than these guys. So that one will have to go. But let's see if we have some continuity here. Yeah, 2.6 ohms. That's good. So I think we can mark the primary of the oscillator coil as being okay. Which I will do. And now we'll go on to the secondary of the oscillator coil right here. Okay, to check the secondary of the oscillator coil, we'll go from pin 4 of the 6A7, and we'll attach to the other side of that same mica mold cap that we just measured across, or measured one end of. So 1, 2, 3, 4 on the 6A7, and this side of the mica mold. And that's giving us 3.6 ohms. Schematic calls for 3.4. So another good one. So the oscillator coil is good. Okay, the secondary grid cap of the 6A7, which I believe is this guy, which you can't see. And then capacitor 7, which is one of these two. Which one is it? It's this one. And that's giving us 6.5 ohms. Schematic says it should be 5.5 plus 1, 6.5. So 6.5 ohms from here to here. I'm going to call that one good as well. It's kind of exciting to be able to mark parts as good on an old radio. That means the odds of it being restored to working conditions are pretty high, and it's less work you have to do. All right, and finally we're off to the primary of the antenna coil. And, the switch is a band switch, pin 2, or switch 2, and in one position it shorts the both the resistor and the coil, this resonance circuit, and just feeds signal directly into this bit of a secondary or primary here. In the other position, this becomes a resonance circuit and probably picks up or responds to a different set of frequencies. I don't know which is which at this point. But in any case, we can go from the fin stock connection on for the antenna to ground, actually, and switch the band switch back and forth and see what we get across here. So where is that? Connector is right here. Antenna, and then to ground. Let's set this up so I can get at the band switch. Antenna to ground. There. We have 0 ohms. If I turn the band switch, although its stops are missing, may have to go all the way around to see if we get a change here. Not seeing anything. This band switch should have just 2 positions. It has all of them and everything in between. My suspicion is that it's screwed up, so I'm not sure. I can't say whether that transformer is working. On the other hand, this is the version 1 of the schematic, and as I recall there was a change. No, the change had nothing to do with that. Well, I guess the thing to do is to find that resistor. That resistor right there is, according to this other schematic I have in my left hand, R2. Let's see if I can find R2. Okay, we found the first significant difference between, relative to the activity we're doing right now. Significant difference between the Type 1, the first release of this radio, and the last one, and that has to do right here in the antenna circuit. This is the first release, and as you can see from the faint stock, it comes in and goes into this resonant circuit here. It's either resonant or shorted, depending on which band you're in, right at the moment. But they added they probably had too much interference from other radio stations, so they added a wave trap in the last version, and it's on this schematic. Very tiny, I apologize, I can barely read it myself, but there's a wave trap right here. So measuring from the antenna to ground was showing me what was going on in the wave trap, as well as this circuit, which may be shorted or may not be shorted. So I've been chasing that down, and there's a component. Let me move your camera a little bit. There's a component right here that isn't in the parts location sheet for version 1, and this is part of the wave trap right here. And the faint stock from the antenna connection goes right to here, then goes through the wave trap and out the other side, which I may presume is right here. Then there's a red wire up to the band switch itself, which makes sense. And then we've got our 10K resistor right here, brown, black, orange, 10K. That's this guy right here, 10K resistor, same as in the Type 1, the release 1, 10K resistor, and across that is the 11 ohm primary of the antenna. So I should be able to measure right across this, and depending on where the band switch is set, it should go to around less than 10K, because it'll be 10K DC resistance shorted by 10,000 ohms of DC resistance. So let's see what we find here. Put this somewhere where you can see it, maybe. Right there, I guess. So I'll go right across this resistor. Yeah, and we're at 10.7 ohms. So 10.7 ohms across this resistor means to me that this coil is good. That's another good coil. And then from one side to ground should be 0.7 ohms. So let's see, I presume it's this side. To ground, any old ground will do. Except that one, apparently. It wouldn't be this side. No. Got to be here. What I'm looking for is this coil right here. I presume it's inside this box. But I want to make sure that this isn't destroyed. If this is corroded away and open, then this won't work properly. So I need to find out. So it's from one side or the other of this resistor to ground. And it should be there all the time, and it is not. Pick up a ground right here. It's open. This side would be the same. Yeah, so that's open as well. So I'm afraid that little pigtail on the antenna coil might be, or that small winding on the antenna coil might be out as well. It's not measuring correctly. So I'm going to mark this as green, and I'm going to mark this as not green. Okay, at this point we have looked at all the transformers. The power transformer, I'm cautiously optimistic that it's all okay. The resistances for the primary and these low DC resistance windings are lower than I would expect, but they're not shorted. The field coil is good. The output transformer is good, both primary and secondary. The primary of the second IF transformer is good. The secondary of the second IF transformer is questionable, but we'll leave that unmarked for now. The secondary of the first IF transformer is good. The primary of the first IF transformer is out. The oscillator coil looks good on both primary and secondary, and the antenna coil looks good on the primary side of this resonant circuit, but this bit right here looks like it's open to me. The secondary looks good. Okay, so it was a long, drawn-out process to measure all this stuff, to tell you my opinions about what needs to be replaced. That capacitor, that capacitor, that capacitor, and this coupling cap right here, again, all need to be replaced in my book before I do anything else, and that I will do. By the way, I have my parts chassis has these two caps in their original condition, so I'll pull those from the parts chassis and put them into this one, so that it looks authentic and original. I'll restuff the caps, of course, but it should be an invisible repair. yeah, so that's next. Next is getting the power supply in some kind of semi-working order. See you next time.